George R. Carruthers, born 1939, died 2020, African-American astrophysicist. George R. Carruthers is best known for his invention of a camera and spectrograph imaging devices which use ultraviolet light to capture images of both Earth and space from the surface of the Moon. A team of engineers built a model according to his design for use during the Apollo 16 mission in 1972, and the resulting photographs provided startling new evidence about ways to control pollution in the Earth's atmosphere and about the presence of hydrogen in deep space. Carruthers was born on October 1st, 1939, in Cincinnati, Ohio. At an early age, he developed an interest in physics, which his father, a civil engineer, encouraged. Carruthers was also an avid science fiction reader and enjoyed constructing model rockets. He grew up on the south side of Chicago, graduated from Inglewood High School in 1957, and entered the College of Engineering at the University of Illinois. He earned a B.S. in physics in 1961 and an M.S. in 1962. In 1964, he earned his Ph.D. in aeronautical and astronautical engineering, with a thesis written on atomic nitrogen recombination. In 1964, he was awarded a National Science Foundation Fellowship in Rocket Astronomy at the Naval Research Laboratory in Washington, D.C. In 1966, Carruthers became a research assistant at the Navy's E.O. Hurlburt Center for Space Research, and here he began the work that would occupy him for much of the next several decades, the development of imaging devices to elucidate the makeup of deep space. In particular, he concentrated on ultraviolet imaging mechanisms and spectroscopy, the use of the color spectrum of substances to detect their constituent parts. In 1969, he patented an image converter for detecting electromagnetic radiation. He then invented the far ultraviolet camera spectrograph, a device which would examine both the Earth's atmosphere and deep space from a location that would avoid the distortions created by Earth. Carruthers' imaging device was designed, in effect, to use the Moon as a deep space observatory. It took several years for the idea to become reality, but by 1972, Carruthers' camera spectrograph was constructed, a gold-plated instrument mounted on a tripod. Commander John W. Young carried the device aboard the Apollo 16 mission and placed it on the surface of the Moon. Over 200 pictures of the Earth's atmosphere and geocorona, as well as of the Milky Way and deep space, were taken from this lunar observatory. Much was learned about the Earth's atmosphere, including possible new ways to control air pollution. Most startling of all was the detection of hydrogen in deep space. This was evidence that plants are not the only source of Earth's oxygen, and the discovery also led to new thinking on the origins of stars. Carruthers' camera was also used on Skylab 4 when it observed Comet Kohatek in 1974. A private man, Carruthers devotes his life to his research and is characteristically low-key about his own contributions. Married in 1973, he has continued to work at the Naval Research Laboratory, developing a telescope to be used in space, as well as other photometric devices. A member of the American Astronomical Society and several other professional organizations, Carruthers won the Arthur S. Fleming Award in 1971, the Exceptional Achievement Scientific Award from NASA in 1972, the Warner Prize, and the National Civil Service League Exceptional Achievement Award. Citations and sources are in the description below.